This is a video from section 3.10. We're going to look at some examples. The directions say find the linearization L of x of the function at A. And so basically what we're doing is we're looking for the equation of the tangent line. So in other words, here's y, here's x. Here we're given the curve y equals f of x. Here's A. Here's the point A, f of A. Okay, so this is y equals f of x, again, and this is the tangent line. And essentially, I want the equation of that line. So this is y equals L of x. So that's what we're doing in these first set of exercises. So if we take a look at example 1, we'll just look at this one. F of x is x cubed minus x squared plus 3. And A equals -2. So if I take the derivative, I get 3x squared minus 2x. And so I need to plug in -2. So I get 3 times -2 squared minus 2 times -2, which is 3 times 4 plus 4. So that looks like it's 16. So this is representing the slope of that tangent line. Now, f of -2 is -2 to the third minus -2 squared plus 3, which is -8 minus 4 plus 3, which is -9. And so we have a slope of 16, and we have a point -2, -9. And so recall, to get the equation of the tangent line, y minus y1 is m times x minus x1. So this is the point slope formula. So y minus -9 is the same as 16 times x minus -2. So y plus 9 is 16 times x plus 2. So y plus 9, distribute the 16, we get 16x plus 32. Solve for y, we get 16x plus, looks like 24, 23. Now, replace y with L of x. Therefore, L of x is equal to 16x plus 23. And that's how you do the first example. So basically, we were just looking for the equation of the tangent line at that point, which ended up being -2, -9. So let's take a look at example 2. Now, suppose f of x is equal to e to the 3x. and then a equals 0. So f prime of x, the derivative of the exponential, so you're going to take e to the 3x, but by the chain rule, you have to take the derivative of 3x, which is 3. F prime of 0 is equal to 3e to the 0. E to the 0 is 1, so this is 3. This is the slope. And f of 0 is 1. And so therefore, the point is 0, 1. Now, we could use y equals mx plus b. It doesn't matter. I mean, we could still stick to the same thing. Y minus 1 is equal to the slope, which is 3, times x minus 0. So y is 3x plus 1. Replace y with L of x. And you're done. And you could say L of x is 3x plus 1. And that's how you find the linearization of the function. We could do one more. Example 3. Suppose I had f of x is cosine 2x, and then a equals pi over 6. Now, f prime of x, the derivative of the cosine function is negative sine. So I'm going to take negative sine evaluated at 2x, but by the chain rule, I have to multiply that by 2. That's the derivative of 2x. So this is negative 2 sine 2x. Now, notice what I'm doing. I'm going to evaluate f prime at pi over 6 because I'm trying to get the slope of the tangent line. So you get negative 2 sine of 2 times pi over 6, which is negative 2 sine of pi over 3. But sine of pi over 3 is square root of 3 over 2. So f prime of pi over 6 is negative 2 times root 3 over 2, which is negative root 3. Now, what I need to do is plug in f of pi over 6 into the original function, right? So I need to take pi over 6, plug it into the original. We get cosine of 2 times pi over 6, which is cosine of pi over 3, which is equal to 1/2. So we have a slope of negative root 3 and a point of pi over 6 1/2. So y minus 1/2 is negative root 3 times x minus pi over 6. And so what I want you to do is solve for y. You get negative root 3x, okay, plus root 3 over 6 pi, because I'm distributing, plus 1/2. Now, replace y with L of x. And so, therefore, L of x is negative root 3x plus root 3 over 6 pi plus 1/2. Now, I want to use these are called linear approximations, by the way. These linear, these are linearizations. Now, what I'm going to do is this. Use a linear approximation to estimate the given number. And I grant you, this all predates calculators, right? But it's still an incredible technique. Now, suppose I give you this one. We'll call this example 4. Well, suppose I give you e to the 0.1. Now, the function, I hope you guys realize, is f of x equals e to the x. Now, I need an a. Can we agree that I need a number nearby 0.1 so that when I take e to the number, I know what it is? And I claim I'm going to use a equals 0. So I know e to the 0 is 1, and 0 is near 0.1. So it's a nice, useful number. Now, f prime of x is e to the x. F prime of 0 is 1. And also note, f of 0 is 1, right? Now, watch what, so basically what I'm doing is I'm looking for the tangent line. So, why, well, here, I'm going to say this first. So, we have a slope of 1. We have a slope of 1, and we have a point 0, 1. And so y minus 1 is 1 times x minus 0, right? And so y is x plus 1. Okay, so that's the tangent line at 0, 1. And so f of x is approximately x plus 1 when x is near 0. Okay? And so f of 0.1. So I'm going to replace x with 0.1, and I'm going to get 0.1 plus 1, which is 1.1. And so therefore, but don't forget, f of x is e to the x. And so e to the 0.1 is approximately 1.1. And if you plug 1.1 in your calculator, so if I take 0.1, I get this. E to the 0.1 is approximately 1.105, 17, on and on and on. That's a calculator answer. So this was a pretty good approximation. But that's how that works. Let's do another one. We'll call this example 5. Well, suppose I had this. Suppose I had the cube root of 1001. So the natural function that we could use here is f of x equals the cube root of x. But by the way, that's equal to x to the 1/3. So before I take the derivative, I need an a. Now, think of a number that's nearby 1,001 that I know the cube root of. And can we agree that we know the cube root of 1,000? That's a number near 1,001 that I know the cube root of. So we're taking a number that I know the cube root of to find a number that I don't know the cube root of. Okay, let me say that again. I'm trying to find a number that I know the cube root of to get me a number that I don't know the cube root of. So I can hopefully approximate it. So I know the cube root of 1,000 is 10. So I'm going to let a be 1,000. So if I take f prime of x, this is 1/3 x to the negative 2/3, which is 1/3x to the 2/3. But f prime of 1,000 is 1/3 times 1,000 to the 2/3, right? But I'm going to write this as 1/3 times, this is the index of the radical, so I could write this as cube root of 1,000 to the second. But the cube root of 1,000 we've already established is 10. So f prime of 1,000 is 1/3 times 100, right? Which ends up being 300. Now, f of 1,000 is cube root of 1,000, which is 10. So now we have a slope of 1/300 and a point of 1,000, 10. Y minus 10 is 1/300 times x minus 1,000. And so y is 10 plus 1/300 times x minus 1,000. And so therefore f of x, but remember f of x is cube root of x. So this is approximately 10 plus 1/300 times x minus 1,000. And remember that this works when x is near 1,000. Okay? Now, so what I'm going to do is I'm going to figure out f of 1,001. And so that's going to be 10 plus 1/300 times 1,001 minus 1,000, which is 10 plus 1/300, which is 3,001/300. Now, again, if you plug that in, I'm going to take 3,001 divided by 300. And that's going to be 10.003. And so therefore, the cube root of 1,001 is approximately 10.003. And let's do one more. We'll call this, that was example 5, by the way. So we'll call this example 6. Well, suppose I had square root of 100.5. This one's good. So I'm hoping you guys realize that f of x is going to be the square root function, which is square root of x. And in this situation, I know the square root of 100. So, and 100 is near 100.5. I know the square root of 64 too, but it's too far away. You know what I mean? And so f prime of x is 1/2 x to the negative 1/2, which is 1 over 2x to the 1/2, which is 1 over 2 square root of x. And so f prime of 100 is 1 over 2 square root of 100, which is 1 over 2 times 10, which is 1 over 20. And f of 100 is square root of 100, which is 10. So this is what we have. We have a slope of 1/20th. And we have the point, which is 100, 10. So y minus 10 is 1 over 20 times x minus 100. So what I'm doing is basically finding the equation of the tangent line first, and that's going to help me approximate the square root of 100.5. So if I solve for y, I get 10 plus 1 over 20 times x minus 100, okay? And so f of x is approximately this amount. So 10 plus 1 over 20 times x minus 100. But now I'm going to replace x with 101. Excuse me, not 101, 100.5. So f of 100.5 is 10, that's my square root of 100, plus 1 over 20 times 100.5 minus 100. So this is 10 plus 120 times 0.5, which is 10 plus 1 over 40, which is 401 over 40. And that's approximately 401 divided by 40. Well, actually, it's exactly 10.025. Now, in the calculator, if I did square root of 100.5, I'll just show you what I end up getting. And this is 10.02496, on and on and on. And so this is a fantastic approximation, and it's much easier to plug it into the linear function than it is to actually calculate that straight on. And that'll conclude this video for section 3.10. We did 3 examples of finding L of x, and then we did 3 examples where we used the linear approximation to estimate a given number. So, okay, thank you.